Welcome to this first video here in building a Beetleweight combat robot. I'm Jason, the creator of Team Robotics. And about 16 years ago, I entered in some robotic combat competitions with the Northeast Robotics Club, which is out in the Philadelphia area. I competed with several 12-pound robots called Mini Flash. And you know what? I found out there's a small community trying to start up around here in southeastern Michigan. So I'm like, well, what the heck? Let's help these guys out and get back into combat robotics, and a 3-pound Beetleweight is a great way to start. Now at this point, I kind of have a vision of what I'm thinking in my head, but the biggest challenge I have right now is figuring out just how big it is. I have a pretty exhaustive list of my ideal components in terms of motors, electronic speed controllers, and stuff like that, but like I said, I really need to figure out how big this robot is, because the real unknown at this point is how much is the structure and the armor going to weigh. So what I'm doing today here is working with Blender to get a concept of my robot. It's very important. It's a concept. It's not a CAD design. I'm literally just kind of blocking out things so I can get an idea of how big stuff is and where the components can fit. And then based on that, I can kind of get the basic dimensions of my structure. Now, one thing you do with Blender, even though it's not CAD software, to help a little bit with the concept things, you can turn on an add-on that's included with Blender called Measure It. So you go into File, User Preferences, do a search for Measure It, click the little checkbox right there, and then hit Save User Settings. And what this allows you to do, you can see this little Show button. You want to click Show when you go to the Measure It tab when you're in Edit mode. And then you can choose different vertices and kind of measure a segment between them. And this is how I'm getting these measurements to appear here in Blender. Now, one thing about them as you go along here, it's going to say they're in meters. It just happens to be the default settings for this particular plugin is that one Blender unit is 1 meter, which is not how I normally work. I normally work with one Blender unit is equal to 1 millimeter, because that's how most 3D printing software and 3D printing slicers tend to work. I'm not too worried about the meters versus millimeters part. It's all about the number. I know these numbers are supposed to be millimeters when I go to do the math. I know this thing is not 50 meters long. That's obviously ridiculous for a 3-pound robot anyway. Then using the basic dimensions of my structure, I could do some math, factor in the density of aluminum or whatever material I'm using, and really figure out just how much this structure is going to weigh. Now, it is important to note that with these pieces here that you see in Blender, even though they look solid, I'm going to be doing some milling work on them to reduce their weight. I just got to figure out exactly what I'm going to do, but that's going to be a little bit later on in this build process. Now, as I'm building the guy here in Blender, what I am doing is I'm looking at reference sheets about the particular components I'm using, whether it's be the speed controller, the motor, whatever, and I'm kind of building something in Blender that approximately matches those dimensions with a little bit of wiggle room, especially like with the wheels. The wheels are a little bit bigger than they're supposed to be because I do want a little bit of extra space around the wheels in case, you know, something goes awry, i.e. battle damage. Then I'm adding in blocks for like the electronic speed controller, the main battery, the receiver, and the weapon speed controller, and of course the weapon motor, and what I call the kill zone of the weapon. I'm not exactly sure what the weapon's going to be, but at this point it's going to be some sort of horizontal spinner weapons. That's why I kind of set up a nice big circular area, because that is what I call the kill zone, as I mentioned just a moment ago. That is where you don't want anything to be, because it will be destroyed by the weapon. Finally, with all these pieces laid out, I can start applying a little bit more details to the structure. You can see that I've got a front and a back plate. Well, it's not truly a back plate, it's kind of a middle plate. And these are going to be aluminum plates, ideally, that are going to be the things that mount all the important components to. Then I need a strong, sturdy weapon mount to hold this thing in place. And there is a lot of unknowns here about just how much strength I need, but what I want to use is 1/4-inch thick aluminum. The problem is 1/4-inch aluminum is actually kind of heavy. When you see the piece I'm holding here, which is 1 inch by 1/4 inch by about 48 inches, it's a little bit over a pound, and so that's definitely way too much for a 3-pound robot. So let me just drop some rectangles in here that approximately match the dimensions I need for these main supports that are going to hold the 2 structure pieces as well as the weapon mounts all together. And then based on that, I can hopefully they'll be in the right weight category. Now it looks like I got a little bit lucky in this case. I was kind of estimating they might be 10 inches long, but they're really closer to 8 inches, actually a little bit under that. So fortunately, they're actually going to be a little bit lighter than I expected, which is really good, because that means I'm now working about 80% of the estimated mass, which honestly was close to almost a pound for these things, even at 10 inches long. What I think I also might do, though, is drill some holes in the back section to save some weight. Hopefully it doesn't compromise the structure too much. Or alternatively, one of the other ideas going on in my head right now is actually make these things out of 1/8-inch thick aluminum. I'd have one piece of the 1/8-inch thick aluminum that runs the entire length of the structure, but then I have a second piece that runs the front half of the structure. So it basically ends up being something around 3/4 of the weight of the current piece. And that may or may not work, may or may not be an option. It's something I got to consider in the future if once I do the math, if things are just still too heavy. Well, there you go. At this point, you can kind of get an idea of more or less what my robot is kind of going to look like. There's still some armor going in there and things like that. But that is going to come in after I figure out just how heavy this stuff is. I've got enough measurements in here in Blender right now to do the math that I need to figure out the weight of things. And then I can go from there to see what I've got left and see if it's actually practical. But all that is going to be done later on in the process. So look for that in a future video of this build process of my Beetleweight robot. Which, by the way, I didn't actually introduce what the name of it is until now. This guy is going to be Micro Flash, naturally, because the robot, like I mentioned, was competed with in the 12-pound class. It's called Mini Flash. It makes sense to go ahead, just drop it down and call it Micro Flash. And it's kind of the same design pattern I used way back in the day for a version of Mini Flash that never quite fought. So once again, I'm Jason, the creator of Team Robotics, and I'm thinking that the goal for this build would be November. That is a bit of a magical world kind of a thing. There is some talk that maybe there's going to be a robotics competition here in the Detroit area around that time frame, so that's why I'm kind of targeting it, but nothing is set in stone at this point. However, go ahead and subscribe to this YouTube channel to get the latest updates on this build and hopefully a few fights as well in the future. So thanks for watching and have a good night.